Today we are diving into not one, but two Ferrari V12s. We're gonna get this one disassembled and fully cleaned up and dry ice blasted in preparation to go in the F40 as our mock-up engine. On this one, we're gonna tear the entire direct injection system off of it so we can go to port injection, and I'm gonna explain why as we do it, despite all of the comments from the last episode. And last but not least, we're gonna 3D scan this engine and draw it up in CAD for our friends over at Hollinger so they can build us that custom transaxle we need. So let's get to it. If you're new here, we're building an F40, but this isn't a normal F40, as crazy as that is to say. What we have is an authentic, original Ferrari F40 body, but underneath it, we'll be building a custom one-off tube chassis along with a lot of custom parts. Our choice of engine is Ferrari's 6.5-liter F140 GA pulled from an 812 Superfast. It produces 800 horsepower and revs to 9,000 RPM. But of course, there's a lot of unknowns. One of the big ones being, will this engine even fit in the car? You guys are going to love how we're going to answer this question later in the episode, but first, I want to get this engine torn down, and I want to do so without dropping any parts down into the engine. And that's why I've printed some of these. It's just a cap for the intake ports. I want to make sure nothing falls down in them as we start taking parts of this engine apart. These ports are some of the best flowing ones that I've ever seen in my limited experience. To be fair, they are a straight shot down at those valves. It's probably why this head flows so well and why this engine makes so much power, but it's also really good for just dropping a nut or bolt down in there, and I've done that before. I don't want to do it on this engine. So I 3D printed these. I based them off of the intake manifold gaskets off of our other engine. Turns out they're not identical. They don't quite fit, but they fit well enough. A couple of bolts still line up and provides a good cap for everything. So this will keep me from dropping anything into the engine. And with these in place, that means we can start pulling this direct injection off and talking about why I want to do that. Now, this will probably come as a surprise to absolutely nobody, but this is the first engine I've ever owned and worked on that has direct injection. So I'm kind of excited to see how it all goes together, even though I want to get rid of it. If you aren't familiar with what direct injection is, it is more or less the latest in fuel injection technology. Instead of having injectors that fire into the ports of the induction system, it fires fuel directly into the cylinder itself, on the other side of the intake valves. This system is extremely high pressure, thousands of psi, in order to overcome the cylinder pressure itself. As a result, all of the parts that make up this fuel system, like the rails and the lines, are all extremely bulky and heavy. Not that it really matters, I'm not worried about the weight of it, but I was surprised to see just how stout these parts are. If they're not valuable based on the Ferrari brand, hopefully they're valuable based on their weight, because I'd like to get a little bit of money back in my pocket. All right, now that we have all of the direct injection stuff pulled off of this engine, I want to take a minute to explain why I'm doing this. And actually, hang on, this rant is a long one with a lot of nerdy details, so I'm going to put it at the end of the episode for everyone that's interested. Stay tuned if you're curious, but otherwise, let's keep the momentum up. Now, as far as these high-pressure fuel pumps go, I don't know anything about them. Clearly, they are driven off of the cam in some capacity, and I have no idea what's going to be involved with eliminating them. I want to make sure that we don't have some sort of issue unbalancing the engine. But I feel pretty good about getting rid of them because if we look really closely here, you'll see that this pedestal for the high pressure pump is actually a separate piece from the head itself. And you can tell that they're kind of using at least part of the same casting from the old engines that did not have direct injection. Beyond that, I happen to know that our friends at OMD in San Diego have just finished up converting their exact same F140 GA over to port injection. They got it running. It's
insane. It's so sick. Their ITB setup is incredible. They removed these pedestals and made their own valve covers, which might just be the coolest custom valve covers I've ever seen. They're inspired by kind of era-correct 80s and 90s F1 valve covers. I am going to have to beg them to make me a set, but that's for a different story. I know that we can get rid of these pedestals as a result, so that's probably something that we're going to pursue.
Now, on top of removing the direct injection peripherals, I want to remove all of the little brackets and tabs that are attached to this engine that we're simply not going to need anymore, or if we do, we'll put them back on in the future. And there's a ton of them. I swear there's a bracket in each and every nook and cranny. On top of that, I want to get this engine fully stripped down, including the engine mounts, because realistically, I have a feeling we're going to make our own. And because I want to 3D scan this engine, I want to get it down to its bare bones, only the essentials, and we can build back up from that point. Even fully stripped down, this is one complicated looking engine. I'll be really curious to see what type of detail we're able to capture as we 3D scan this thing. There's a lot of shapes that could prove difficult to capture, especially down in the valley of the V, where there's a lot of details that we might want, especially all of the mounting locations for the original DI injectors.
Now, some of you may be wondering what these dots are and why I'm sticking them everywhere. If you've watched any sort of 3D scanning stuff before, you've probably seen them. There's also probably a correct term for them, but I'm just gonna call them like locator beacons or something of the sort. They're these like reflective stickers that are basically present to help the 3D scanner understand where it is in 3D space. It's gonna be able to see these no matter what, and it helps it's gonna read them and kind of make a pattern out of them, and then as they move around, it's gonna understand where it is in relation to these dots. I don't know if that makes a ton of sense as an explanation, but in short, in order to scan this, we need them. And the more we have, the easier it is for the scanner to understand where it is and to not kind of get tripped up and confused and kind of tell us, hey, I'm lost, move me around until I can kind of figure out where I am again.
At least I assumed I would need all of these beacons because in the past, for all of my 3D scans, I've had a lot of trouble with the 3D scanner understanding where it is in 3D space. But I've got a new tool in this episode to show you guys, and as I've come to find out, it works a lot better than our old one. The team over at Creality have brought forth a serious upgrade. Inside of this box, we've got Creality's new Raptor X 3D scanner, and this thing is the world's first wireless blue laser and near-infrared scanner all in one unit. Now, obviously, I'm excited for this thing's accuracy, which is down to 0.02 millimeters, or just under 1/1000th of an inch. But just as importantly, it's wireless, which means I'm no longer tethered to a laptop in the middle of the shop that can barely handle this type of stuff. It's also capable of capturing something the size of an SUV in a single scan, so as said, this is a major upgrade to our scanning hardware. So a special thanks to the Creality team for getting this thing sent over to us and helping this project along. Now let's talk a little bit more about why I want a 3D scan of this engine and how it's going to help us. I've mentioned that I want to design things like engine mounts, exhaust flanges, intake flanges, and other things, but there is more to it than just that. Having a CAD file of this engine is going to be a huge advantage as we get further into the project. I'm not designing the chassis itself in CAD, I'm going to build it by hand the old-fashioned way, but once we get the base structure built, we're going to scan that as well, and we're going to pair everything up in Fusion 360, and that'll allow us to design all of the accessories for this vehicle, such as the brackets, the tabs, the mounts, and everything that'll make it actually work, in Fusion, and then we can rely on our friends at SendCutSend to help get this car built. But in the meantime, this 3D scan will answer the question of whether or not this V12 will actually fit inside of an F40, which we'll answer later in the episode. Now to help with all of this CAD work, we do have another major shop upgrade, and that is a new shop PC from Orbital Computers. This thing is specifically engineered for 3D CAD work, and if you're a computer nerd, you're going to love the specs on this thing because it is an absolute powerhouse. For starters, it's got an Intel Core i9 14900KF processor, and it's pairing that with 128 gigabytes of DDR5 RAM and an NVIDIA Quadro RTX 2000 graphics card, which is catered specifically to CAD work like what we're doing. I am not as savvy with computers as I'd like to be, so the fact that Orbital Computers has pre-built machines like this one for jobs like this is hugely helpful, so another thanks to Orbital for getting us set up in a meaningful and powerful way. Now what about that other V12?
Last week I showed you guys our F140 V12 that we're going to be swapping into our F40 project, and then I showed you guys this, a second V12. What on earth do we have a second one for? Because you might already have noticed it's got a real big problem with it. Honestly, I bought this before we got our F140 GA. I knew what we wanted to accomplish, that I wanted a Ferrari V12, but I didn't know when I would find one, and so I said, we're gonna need an engine in order to start building this car. So much of it has to be built around the size and shape of this thing and how we're gonna mount it, how everything's gonna be bolted to it, exhaust manifolds, intake, all of the plumbing. There's a lot that hinges around this engine, and we need one to build the car. And under the assumption that we weren't gonna find one anytime soon, I managed to acquire this beautiful piece of machinery. No, we're not gonna be able to save it. We're not even gonna try. All we're gonna do is use this for mock-up. But with that, I wanna get it cleaned up because it's filthy and disgusting, and I think it'd be a pretty fun project. I don't wanna look at this for the next 2 years. Now, if you're wondering what engine we actually have here and if it's the same thing, the answer is no. This is actually a bit of a different variant that's from a Ferrari FF. When the Ferrari FF came out, highest production horsepower NA engine in the world, kind of a trend for these F140 motors. But if we look at the front of this thing, you'll notice it looks quite a bit different than the front of our other engine because the FF is all-wheel drive. And I entertained the idea of maybe trying to make the F40 all-wheel drive as a result too, but this is meant to be in the front of a car and it just wasn't gonna work the way we want to, and F40 needs to be rear-wheel drive anyways.
But on top of a block, we need heads, and so I sourced a matching pair from a GTC4 Lusso that was in a very serious fire. I have a feeling that this fire was caused by a relatively similar issue as the FF engine failure because this thing has some very beat up valves that are clearly bent, and I think it might have exploded catastrophically. But thankfully, none of that really matters in our case. We just need an engine's external dimensions so that we can build a car around it. So let's get all of these parts over next door to below zero dry ice cleaning so that we can get it cleaned up because, as said, it's going to be a long time before we put our good F140 GA into the F40, and I don't want to deal with or work with a nasty, disgusting engine for the next couple of years. And yeah, I can already imagine some of you guys are in the comments saying, this isn't the interesting progress I want to see some real fabrication, and trust me, I'm with you, I want that too, but that doesn't change the fact that this is still some necessary stuff we've got to get done if we want to build this car. We're pretty fortunate that Joel next door at Below Zero Dry Ice Cleaning is allowing us to use his equipment because this stuff is expensive. But as you can see, the results are well worth it. This time-consuming process is more or less unparalleled when it comes to cleanup. And if you're asking me, it's also some of the most satisfying footage I've ever put on this channel. Just wait till you see how incredibly clean this engine is about to get. In total, I spent a few hours on cleanup between the block and the cylinder heads, and even that wasn't enough to completely finish the job. After I called it a night, Joel was kind enough to come in and finish all of the small details so that this engine really looked the part. It is some seriously dirty work, but the payoff is well worth it, and I'm excited for you guys to see the end result.
I know I said these were light the other day, and relatively speaking, they are, but good lord are they also heavy. Oh my god. But they look pretty good. They look a lot better than they did. I'm excited about it. Goodness, what a difference. All right, now to move a block. We'll set it right there. You ready?
Yep.
Okay. All right, you get your tail end on there. See if you can get up there. You got it?
Yep.
Okay. Let's do that. It looks a lot better than it did before, huh?
What's going on here? Where'd this motor come from?
He didn't watch the other episode.
As you can see, there is a night and day difference in how clean this engine is, and it's going to make it a lot nicer to actually work with and manipulate as we move forward. So the obvious next step is to get it put back together so that it's a complete engine, or at least close enough to one.
Yep. Your way of hair. There you go.
There it goes. Perfect.
Cool.
Yeah, hit it. Feels good, doesn't it?
Feels good.
All right.
Perfect.
Mike's Pretty Good Ferrari Head Installation LLC. Give me a call. I'll get you set up.
With the engine loosely assembled, it's time to get it off of the workbench, but as you guys know, I care a lot about weight when it comes to this project, and I had to satisfy my curiosity to find out exactly what this engine, without the rotating assembly, actually weighs. Surprisingly, it's even lighter than expected, about 280 pounds in total, as a fully loaded engine, minus the crankshaft, the rods, and the pistons, or at least 11 pistons. With that, we can cross one job off the list. We have our engine ready to go into the car. And it's pretty cool to see both of these V12s side by side. Yeah, I know one of them is legitimately junk, but still, there's two Ferrari V12s sitting here, and that is pretty sick. Now back to that 3D scan we were working on earlier. This is the finished result after processing in Creality's software, and I've got to say I'm really happy with the outcome. There is an insane amount of detail packed into this model, given that it has 11 million faces and about 250,000 data points in order to build it. You can make out the part numbers on the timing cover or down in the valley of the engine. You can see every single beacon marker that we stuck to it, and of course all of the important data that I was hoping to get off this thing is present and legible. And this particular scan is an infrared scan, which means we could get even more detail with the blue lines if we wanted to, but this is detailed enough. And it only took about 15 minutes to scan in total, and a similar amount of time to process. Now, for those not in the know, while this scan is useful by itself, it's not as useful without real physical measurements off of the engine itself. So let's get out the calipers and get to work. It's important to think of a 3D scan as a reference, or a facsimile of what we need versus the real thing. We're going to be able to use the 3D scan and actual physical measurements to draw the engine in CAD. The scan itself isn't a workable model, it just looks like one. The best analogy I can come up with is to think of a 3D scan as a digital version of tracing paper. It's going to help us draw the engine in CAD, and with these measurements, we can know that it's truly accurate. Now, to showcase all of this, I want to rewind a little over a month because that's when I started on this transmission project. You can see here I've got a 3D scan of just the back of the engine. In red, I've modeled parts of the back that actually matter. We've got the geometry of the crankshaft so that we can design a flywheel, and then anything that the flywheel could foul with once it's drawn up. On top of that, you can see some of my digital sketches represented in orange, blue, and purple. This represents the geometry of the back of the engine, and it's important because we need to give this information to Hollinger so that we can have a custom transaxle built for the car. So let's turn our attention to that because it's the important next step.
Now, what I have here is a model of one of Hollinger's gearboxes, one of their transaxles. It's really similar to what we're gonna put in the F40, but obviously it's not the same because it doesn't exist yet. Primarily what we need to give them is the information to change this orange face where the gearbox bell housing mounts to the block. That's what they're gonna need to design and change so that their gearbox and our engine interface correctly. This model has been really cool to look at. It's got a ton of really cool parts on it. Get to kind of see how it works. It's really technology dense. We can see some of the air actuators on it, the way they have the starter set up. This thing is incredible. And looking at this model, it makes me want to take one more opportunity to explain my choice of gearbox, because it's really clear to me after comments, even in the last episode talking a bit about it, that a lot of people don't even understand what this gearbox really is. Understandably, when I call it a sequential manual gearbox, some people immediately go to thinking of BMW's SMG of the same name. This is nothing like that. This isn't really anything like any gearbox that you're gonna find in any sort of production car. This is some real race car stuff, but it is undoubtedly and unquestionably a manual gearbox. It has a clutch. It has a clutch pedal. We're gonna have to use it to start and stop the car. We just don't use the clutch during shifts. This is shifted pneumatically. I'm using paddle shifters, but that's no different than grabbing the handle in the 308 or the 244 GTK. We're just not using a cable to do it. We're using paddles and pressurized air to tell this thing, hey, move the selector fork this way or that way, or the shift barrel, if you will. This is a manual gearbox. We have full control over it. We're not using something like a DCT, something you might find in a modern production car. This is nowhere close to that. This will probably be the least street-friendly part of the car. It's gonna be a straight cut gearbox, and it's gonna be a tough thing to drive, but I wanted the best of the best. That's why I went to Hollinger. I wanted the gearbox that was gonna hold up to the 800 horsepower this transmission's gonna put out. And of course, I wanna make sure that I'm not gonna be breaking it. I don't wanna be tampering with it. I want something that's gonna work. And so I said, hey guys, let's build something perfect for this vehicle.
But now we get to do the cool part where we pair the transmission model with the 3D scan of our engine. And like I said, technically they don't interface properly yet, but we can still line up the crankshaft with the input shaft of the transmission to get an idea of how they will sit together and what the overall packaging constraints are going to look like. I think this really illustrates just how small the flywheel packaging is on the V12 in contrast to a more normal platform, such as a Ford Coyote, which is what this transaxle normally attaches to. You can see what crazy-sized adapter we'd need if we wanted to put an off-the-shelf gearbox on this V12. It just wouldn't work well. But cooler than any of that, of course, is putting this inside of an F40. This is one of the coolest things I've ever done in CAD. What we have here is a dimensionally accurate Ferrari F40, at least on the outside. It's ripped from Gran Turismo, so the dimensions are perfect, although the insides are a little bit arbitrary, but that is okay. We are not, to be clear, worried about clearance to the driver's seat. It isn't accurate. But what is where the engine sits in relation to the rear wheel centerline, and what kind of clearance we can have inside the shell of the F40, because that is what we have to work with in real life. It gives us an idea of where the driver's seat can sit in reality, and honestly, it's not much further forward than what we see in this model, which is further back than real life. So again, this proves that the V12 is going to fit inside of the F40 without any issue at all, especially considering we don't have any real constraints inside to work with. Some of you will probably notice that I do have the outputs of the gearbox shifted further back than the center line of the rear wheels, but it is the same offset as stock, and it should be more than happy with CVs. Now again, I want to iterate that this is not exact. The engine and the gearbox are correctly sized, as is the outside dimensions and shape of the F40. This is really just a proof of concept, but it's really cool to be able to do this kind of thing in CAD. This is the type of thing I never imagined I'd get to do with the onset of this YouTube channel, but here we are working with stuff that feels space age with respect to technology, and we're going to get to incorporate it on a car we're building right here. This is awesome, and I'm excited to see just how far we can take technology with this project.
So we have our engine scanned and we have all of the information sent over to our friends at Hollinger so they can start building and designing that gearbox for us. and before too long, we're gonna have a 3D printed one in hand to use as a mock-up. We're gonna need it. We also have our other engine all cleaned up and ready to go in the car, which we're gonna get in place in the next episode. We've got to figure out exactly where it's gonna be thanks to the model that I showed you guys earlier. I'm really glad that we have that kind of stuff, and I'm also really glad that we have this workstation permanently set up in the shop. Orbital Computers did us a huge solid by getting us this computer machine dedicated to this type of CAD work. The scanner is also great to have, not tethered to a cable anymore. Both of these things together are really going to change the things that we can do in this shop, and I am stoked for it. And I hope you guys have been enjoying the technical side of this, the digital side of this project so far, but I know you're also wondering, when are we going to dive into the cutting and welding, the actual build portion of this project? And I promise you, I want that even more than you guys do. I am super eager for it, but there's a few hurdles that we're waiting on. Primarily, I'm waiting on our chassis material to arrive. As far as what I've chosen, we are going with Docal R8. Now there's a few different materials we could use. There's DOM, mild steel, not an option for this project. And there's chromoly 4130. It's a great material for this, but it has some drawbacks. While Docal R8 is specifically engineered for motorsport purposes, it gives us a really good allowance for our tubing material thickness, as far as what we can do, and I'm excited to weld it. I haven't welded Docal R8 before. I've built a lot of parts out of it, lots of cages and structures, but no welding, so I'm excited to take you guys on that part of the journey too. Just got to be patient while we wait for it. We've got the holiday that just passed, and we've got another one coming up, but it's going to get here, and when it does, we're going to hit the ground running and dive into the cutting and welding side of this project. But we got to get everything working, all of our ducks in a row, all of the irons in the fire, and this stuff is critically important too, which is why I've been showing you every step of the way. I hope you guys have enjoyed it. We'll be back next week. We'll get the engine in the car and start planning out all of our dimensions, and I'll see you guys then.
But as promised, before we go, here are all of my thoughts on why I want to get rid of direct injection, and I think this is a good one, so let me know what you think in the comments.
All right, now that we have all of the direct injection stuff pulled off of this engine, I want to take a minute to explain why I'm doing this. And if you don't want the nerdy, detailed explanation of all this stuff, you can just skip ahead, that's okay. But for all my nerdy friends out there, here we go, we are diving in. I'll preface this by saying, I know a lot of you guys out there simply will not agree with my decision, no matter how many justifications I make or how right I believe that I am. We're just not going to agree on this, and that's fine, I don't care. But some of you were really curious as to why I would do this, because obviously Ferrari did this for a reason, and a lot of people believe that this direct injection system is part of what makes this engine so good, and I'm here to argue otherwise. So let's start at the top. Power, the most important part of this whole thing. Is this the reason this engine is as powerful as it is? Well, the answer, in my opinion, is no, and I will prove that later down the line once we get this running on port injection. Direct injection has a lot of benefits to it, namely efficiency, fuel economy, and its cleanliness or emissions. They both allow this engine to run a lot better, a lot more efficiently, and yes, there is a power benefit too, but that primarily comes from the fact that direct injection allows you to have a much higher compression ratio. This engine is 13.5 to 1 compression. Before direct injection, this would be a balls out race engine. You could not run this on pump gas, especially not 91 octane. But with direct injection, you can. So what are we going to do to circumnavigate that or get around it? Well, the answer is E85. By running E85, we can run this on 13.5 to 1 compression, and we're not going to have any problems with cooling. These do have a cooling effect with the engine. We're not going to have to worry about that. E85 is going to outcool any sort of direct injection benefit by a massive, massive margin. It's an amazing fuel in that regard. It's also really high octane. It's really kind of going to get rid of all of the issues in that regard. Direct injection is also really dirty. If you look in the ports of any direct injection engine or talk to anybody that has to work on them, they're going to tell you that it is just nasty for an engine. It's really not good for the engine itself, other than kind of airflow and whatnot. You're not having to have your fuel go around the valves. You're going to have a kind of a better burn in the cylinder, but again, E85, we're not going to have that issue. As far as emissions go, well, we're building an F40. I'm not worried about it. And as far as efficiency goes, well, one, E85 is really cheap. Two, you burn a lot of E85 in order to run it, so I'm not really worried. And three, fuel economy is not something that anybody with any form of F40 whatsoever should be worried about. So all of those are going to go right out the window. Now, some people are going to ask, Ferrari did this for a reason. Why would you undo it? And my answer is Ferrari did this because they have to, not because they want to. Now, again, I will admit there are some benefits. You can probably extract a little bit more performance out of a DI motor, but these are also going to have a lot of limitations when it comes to tuning and fuel. If we want to run these, we're not going to be running E85 through them. We're going to hit a ceiling on how much this injector can flow, and then we're going to be modifying the whole direct injection system, and that's going to be a headache. On top of that, tuning direct injection is not an easy thing to do. The tuning window to get everything correct is very small. The information available for this engine is very limited. Doesn't mean that we couldn't get it or that we couldn't make this work on direct injection, but it's a headache that I don't want to deal with, and there's not a reason to do it. There's not enough juice to get from that squeeze if we're going to go down that path. If I thought that we were going to retain a lot of horsepower from it, I'd say sure, but there is no reason in my eyes to keep direct injection. The biggest reason all of the commenters in the last video kind of chimed in on is that we're going to nuke the power of this engine. But I want to break a few numbers down and talk about that because I really don't believe that it's true whatsoever. And the basis of that is going to be Ferrari's Enzo engine, the 6-liter predecessor to this engine. Made about 660 horsepower versus this one's 789. Now there's a half-liter difference between this engine and that one, and some very rough napkin math gives us about a 10% delta in overall displacement. 10% delta in displacement for the same engine is going to give us a 10% power increase if we increase by that 10%. That means that this engine, set up exactly the same way, would make, instead of 660 horsepower, is going to make another 50 or 60 horsepower on top of that. We're already going to be in the 700s. And then the Enzo engine, if I remember right, it's 11-to-1 compression versus this 13.5-to-1 compression. That's a huge jump. There's going to be a lot of power on the table there. Plus, we're going to have different cam timing and advancements. The head's going to flow better, all that kind of stuff. I think port injection will make within 1 or 2% of the exact same power before we start tuning this thing and pulling power out of that side of the equation and making more. There are guys making well into the mid 700s at the wheels on these cars, and I think we can see that or more depending on how aggressive we want to get, because we're not going to be limited by the original direct injection. Now, last but not least, and I know this is long-winded, there is the standalone side of this. There are only a handful of systems out there that will run direct injection. Motec will do it, Life Racing will do it, and there are some other systems that are a bit more affordable. I think that Fuel Tech and Link both have a system that will run direct injection. And some of you pointed out that the Haltech we're running will not do that. And while you are correct, it doesn't mean that we couldn't probably find a workaround using like a Life Racing direct injector driver. But again, I don't see any reason to keep this stuff. I want to be able to tune this car at the track, or anytime we make changes, if I want to modify, improve it, and really kind of revamp the car at any point. I don't want that annoying tuning window of direct injection. And before anybody criticizes me and says that I don't know what I'm talking about, if you join our StanceWorks Discord, especially the private lounge, we've actually got some OEM direct injection guys that work for the big brands that know exactly what they're talking about and tune this stuff for a living. And even they are in there telling me, dude, get rid of this stuff. And there's a reason that all those LT4 Corvette guys are getting rid of this stuff too. It's not worth keeping. There is no advantage to us because we don't need to meet those emissions and efficiency requirements. And I want this thing to run at its peak. And I believe port injection is going to get us there. Enough about that. Let's continue the teardown.